And then the IP communication. When the PCs, when the host want to communicate with other host, with another host, the PC first should decide what is the destination located. Okay, if the destination IP address and the IP address, the network part is the same as the sender's network part, then that means these two hosts exist in the same network. So the hosts can send direct to the destination, send the packet direct to the destination. But if the sender wants to sending to the destination that have different network types, here, the network type, the network address are different from the source, then the source will not send to the destination. Okay, the source will find the gateway. For example, if you deploy a router in between these two networks, then this address is the gateway. Then the source will sending the packet to the gateway. Okay, then the gateway will searching in the routing table and then sending to the destination. Okay, the different network parts, the IP address, the different network parts, you cannot, of course, you can configure into device that connect in one network, yeah, but they cannot communicate. They cannot communicate. For example, this is .1.1, and this is .2.1. They cannot communicate, okay? Because they regard them are separated in different network segments, okay? And then we go to the subnet mask. In the class A, class B, class C system, we did not use the network mask. That means if you see address that's the 192, then this number you can decide this is the class C. Then you can decide the mask length is the 24. Okay, the mask length 24 means the network part is a 24 bit long and the host part is 8 bit long. Okay, this is the default network mask. But how to represent? We can use the network mask. The network mask is divided into two parts. One part is a series of ones, and another part is a series of zeros. The ones part means to identify in this IP address, the ones part are network part, And the zero part are host part. Then, use the network mask. We can divide the network IP address into two parts, the network part and the host part. So, by default, the class A, class B, and the class C have a default subnet mask. As we know, in the class A, the first 8 bits are network parts. So the mask for the class A should be as this, 255 and then .0.0.0. Okay, and then the class B, as we know, the class B, there's 16 bits used for the network part. Okay, so the network mask for class B should be 255, 255, and 0 and 0. Okay, and for the class C, there's 24 bits used for the network part. So the class C, the mask should be 255, 255, and 255.0. Okay, this is the network mask, the default network mask for class A, class B, and class C. Okay, and then we can see the address plane. For example, now we got the IP address and the subnet mask. This is the IP address 190, 192, and 168 and .1.7. Okay, then this is the mask. The mask said there's 24 bits. Yeah, the first 3 bytes used for network identification, and the last 1 byte is used for host. Okay, and then we can see this part is a network. Okay, when the host part is all zeros, we know that all zeros is a special IP address. This IP address is represent the network as a whole. Okay, the network as a whole. So this is the network address. This is a network address. Okay, then the host part, we have 1 byte. That means the host part, there's 8 bits long. The 8 bits long. So how many IP address, how many values can this part represent? Okay, we can see this is 2 powers 8. So the value should be 255 values from 0 to 255. Okay, that's 256 values. But as we know, all these values, there are 2 specials. That's all 0 value is represented the network as a whole. Okay, so this value cannot configure on the host. Okay, and the 255, that's the all ones value. All ones value we have discussed, it's represented the broadcast. Okay, so this value also cannot be configured on the host. So how many values can be configured as the IP address on the host? That's the 2 powers n. That's the 8. Okay, 2 powers 8 minus 2. So the valid IP address that can be configured on the host is 254. Okay, this is how to calculate the available IP address in the network when provided by the IP address and the subnet mask. Okay. Then we got a case to identify, to practice. Okay, this is the IP address and this is the subnet mask. And we know now this is the subnet mask divides the IP address into 2 parts. This is the network part. This is the network part. And there are 2 bytes. There are 16 bits long. Okay, 16 bits long. And the host part, also there are 16 bits long. Okay, and then what is a network address? Network address means the host part are all zeros. So the network address is 172 and then 16 and then 0 and 0. Okay, and then the host address, how many values can this choose? Okay, and then That's the 2 power 16. Okay, 2 power 16. Okay, just that's the 655 and 35. Okay, and how many address can be used? Okay, yeah, the range is 6. Okay, 2, 6, 5, 5, 3, 6. Okay, this is all the values. The range is from 0 to 6, 5, 5, 3, 5. Okay, this is the numbers of value that's included in this range. Okay, 2 byte, 16 bit. Okay, and then the varied means the 0 cannot be used, and then all ones also cannot be used. So the varied IP address can be configured on the host is 6, 5, 5, 3, 4. Okay, this is the number of IP address that can be configured on the host included in this network.